Hello, good morning everyone. So today we will discuss about earthquake resistant structures and introduction part to it. So I will start by sharing the PPT presentation which I had made for it. I hope it is visible to you all. Is it visible to you? So in the module 1, we are supposed to study about introduction to engineering seismology. Next, general features of earthquakes with regard to Indian continent, geological and tectonic features of India, origin and propagation of seismic waves, characteristics of earthquake, magnitude and intensity scales, seismic instruments, earthquake hazards in India, earthquake risk evaluation and mitigation, structural behavior under gravity and seismic loads, lateral load resisting structural systems, requirement of efficient earthquake resistant structural system, damping devices, base isolation system. So starting with introduction to engineering seismology. So what do you mean by exactly seismology? So seismology is nothing but branch of geophysics concerned with the study and analysis of earthquakes and the science of energy propagation through the earth crust. So engineering seismology is concerned with the solution of engineering problems connected with earthquake. So as you know that earthquakes are nowadays normal, although in India the earthquakes are occurring in not so many places, but Gujarat or what you can some Kutch in such places you can expect earthquakes. In Japan, earthquakes are very much. Now, coming to seismology is extremely important. Why the study of seismology is important for a civil engineer? Seismology is extremely important because it helps us to study of earthquakes, gives us important clues about the Earth's interior, and also understanding earthquakes allows us to minimize the damage and loss of life. When we come to know about the earthquake, although prediction of earthquake is not possible, but we can just minimize the damage of loss of life if we take some precautionary measures. So now the question comes, what exactly mean by earthquake? So an earthquake is the vibration of earth produced by rapid release of accumulated energy in elastically strained rocks. Energy release radiates in all directions from its source. The focus of energy propagates in the form of seismic waves. Sensitive instruments around the world record the event. So, what exactly is earthquake? Earthquake is nothing but the vibration of earth produced by rapid release of accumulated energy in elastically strained rocks. So, as you know that there are different types of rocks available, like metamorphic rocks, igneous rocks, sedimentary rocks. So, the vibration of earth produced by rapid release of accumulated energy in this type of rock is known as earthquake. So there are different instruments used to measure the energy released due to an earthquake. So now the question comes, what exactly causes an earthquake? So the movement of tectonic plates. So as you know that the earth is divided into sections called tectonic plates that flow on the fluid tectonic plates. On the that flow on the So there was a technical problem. Sorry for the inconvenience caused. So what exactly causes an earthquake? So the movement of tectonic plates. So as you know that the earth is divided into sections called tectonic plate that floats on the fluid like interior of the earth. So earth is divided into tectonic plates. The earthquakes are usually caused by sudden movement of these plates. So as these plates move over one another, there is the possibility of formation of an earthquake. Ruptures along a fault. Faults are localized areas of weakness in the surface of the earth, sometimes the plate boundary itself. So, apart from the movement of tectonic plates, an earthquake is also caused due to rupture of rocks along a fault. Now, the question comes, what do you mean by faults? Faults are nothing but localized areas of weakness in the surface of the earth, sometimes the plate boundary itself. So, the plate boundary itself can act as a fault and causes an earthquake. So where do earthquake occurs? Now the big question comes, where exactly the earthquake occurs? The focus and epicenter of an earthquake. What is the focus, main point, or the starting point of an earthquake? The point within earth where faulting begin is the focus or hypocenter. So the point, initial point from where the earth start faulting or deteriorating is known as your focus, and one more name is given to it, it is known as hypocenter. The point directly above the focus on the surface is the epicenter. So 3 points you have to remember, that is focus, hypocenter and epicenter. So now we will see what are the different types of seismic waves. Earthquakes produce three types of seismic waves, namely primary waves, secondary waves, which are also termed as body waves, and one more wave is that is known as surface waves. Each type of waves move through materials differently. So broadly, if you classify the waves, there are two types of waves, that is body waves and surface waves. And each type of wave moves through materials differently. In addition, the waves can reflect or bounce off boundaries between different layers. Apart from these waves, there are other types of secondary waves also, which we will see later. So now coming to the brief explanation about primary waves. What exactly you mean by primary waves? The fastest seismic waves which reaches the earth first are called primary waves or P waves or pressure waves. So how you will define primary waves? The fastest seismic waves which reaches the earth first. The waves which reaches the earth first are termed as primary waves, or it is also known as pressure waves. These waves are the first to reach any particular location after an earthquake occurs. Primary waves travel through earth crust at an average speed of about 5 km per second. It is also very important. What is the speed at which the P waves reaches the earth surface? So, what is the speed? 5 km per second. Primary waves can travel through solids, liquids, and gases. So, these primary waves can travel through solids, liquids, as well as gases. As they pass through a material, the particles of the material are slightly pushed together and pulled apart. Buildings also experience this push and pulls as primary waves pass through the ground they are built on. So these primary waves travel through solid, liquid, and gases. Apart from primary waves, they travel through solids, liquids, as gases. Then only they will reach the Earth's surface. As they pass through the materials, the particles of the materials slightly pushed together and pulled apart. Buildings also experience this push and pull as primary waves pass through the ground they are built upon. So this is the brief explanation about primary waves. Now coming to secondary waves. Secondary waves are the second seismic waves to arrive at any particular location after an earthquake, though they start at the same time as primary wave. So primary waves and secondary waves, they start at the same time. But what they will do, primary waves will reach the earth's surface first, later on the secondary waves will reach. Secondary waves travel through the Earth's interior at about half the speed of primary waves. So, as we are aware that the speed of primary waves was 5 km per second. So, the speed of secondary waves is almost half the speed of primary waves. It is almost 2.5 km per second. Secondary waves are also called S waves or shear waves. As primary waves were called as P waves or pressure waves, similarly, secondary waves are also called as S waves or shear waves. As they pass through a material, the material particles are shaken up and down from side to side. So, as the secondary waves or the S waves pass through the materials, what they will do? They shaken up the entire material from down or side to side. Secondary waves rock small buildings back and forth as they pass. So what the secondary waves they will do? They will push the small buildings back and forth as they pass. Secondary waves can travel through rocks, but unlike primary waves, they cannot travel through liquids or gases. See, primary waves can pass through solid liquid gases, whereas secondary waves can only travel through rocks, but they cannot travel through liquids and gases. Now, surface waves. So, initially, what we said, there are only two types of that is pressure waves and P waves and S waves. But apart from these two waves, there are another type of wave known as surface wave. These surface waves are seismic waves that move along the Earth's crust, not through its interior. They make the ground roll up and down or shake from side to side. Surface waves cause the largest ground movements and the most damage. Surface wave travel more slowly than the other type of seismic wave. See, although the speed of surface wave is less compared to your primary wave and your secondary wave, they cause a lot of damage when you compare with primary waves and secondary waves. These surface waves are the most severe waves. Now coming to seismograph. So what is seismograph? Why it is used? Seismograph is nothing but it is an instrument used to measure the intensity of earthquake produced by this wave. In reality, let's check it. No, if we will check it will be so it will be somewhat blur. So we will skip this. Now we will come to characteristic of earthquake. magnitude and intensity scales, seismic instrument. So it is also very important for. So how you can measure earthquake? We can predict earthquake, no, but we can measure the earthquake, or we can calculate the intensity of earthquake cost. So the earthquake can be measured in two ways. Two ways. First method is based on magnitude, that is amount of energy released at the earthquake source. How much amount of energy is released at the earthquake source. The other is based on intensity, how much the ground shakes at a specific location. So based on these two ways, we can calculate the earthquake. Although several scales have been developed over the years, the two commonly used today in the United States are the moment magnitude scale, which measures magnitude M or size, and the modified Mercalli scale, which measures intensity. The two commonly used the two commonly used today in the United States are the most magnitude scale, which are magnitude scale or the size, and the modified Mercalli scale, which measure intensity. So how you will measure the earthquake? Two scales we have developed. First is the moment magnitude scale MMI, and the modified Mercalli scale, which measures intensity. Measurement of the moment magnitude scale are determined using a complex mathematical formula to convert motion record with a seismometer into the magnitude number that represent the amount of energy released during an earthquake. Energy released for each whole number measurement is about 31 times greater than that released by the whole number before. So it is somewhat complicated. What we can understand is measurements on the mode magnitude scale are determined using a complex mathematical formula to convert motion recorded with a seismometer. See, seismometer directly it will not give the reading. This much is the intensity of earthquake, this much is the magnitude. There are certain formulas for calculating magnitude earthquake. For example, a magnitude 2 earthquake is 31 times more powerful than a magnitude 1 earthquake. Normally, if you see magnitude 1 or 2, you will not be able to understand how much is the difference between the two earthquake. So, how we are understanding, for example, a magnitude 2 earthquake. Suppose an earthquake occurs in Gujarat, its magnitude is 2, and one more earthquake occurs in, say, somewhat Pondicherry, something like that. It is of magnitude 1. So, what is the difference between the two? A magnitude 2 earthquake is 31 times more powerful than a magnitude 1 earthquake. The moment magnitude scale is often referred to by the name expressed the Richter scale. See, moment magnitude scale is normally not used nowadays. Which scale we are using is Richter scale. You might have heard on the Richter scale, then intensity of earthquake was measured as, and the magnitude of earthquake was measured as this much. So Richter scale we are using. Measurements on the modified Mercalli intensity MMI scale ranges from 1 to 12 and are based solely on the damage assessment and eyewitnesses account. Intensity measurements near the force of an earthquake are generally higher than those at a distance. So one more scale is there to measure the magnitude of earthquake, that is known as measurements modified Mercalli intensity scale MMI scale, and it is calculated in from the range from 1 to 12 for woman. What numbers are used for the assessment? Determining intensity can be difficult in sparsely populated areas with few buildings because intensity is calculated largely based on the effect that tremors have on human made structure. Although an earthquake magnitude and intensity measures are not precisely comparable, they can in general be correlated when intensity measurements nearest the epicenter are used in the See, determining intensity can be difficult in sparsely populated area. Suppose if the area is very populated, less populated, and with few buildings, it is very difficult to determine the intensity of earthquake. Although an earthquake magnitude and intensity are not precisely comparable, They can in general be correlated when intensity measurement near the epicenters are used in comparison. So epicenter can be used as a tool for determining the magnitude intensity of an earthquake. The magnitude of earthquake that occurred before the introduction of the Richter scale in 1935 are estimated based on reported damage and intensity. Seismologists categorize measured and by the not by their intensity. So Richter scale was introduced in 1935. Before that also there was an earthquake. So how we will calculate the earthquake? In 1935, Charles P. Richter proposed a equation which gives the magnitude of earthquake by using the amplitude and correlating with the energy release. That is, m is equal to log a minus log a naught, where a is the recorded amplitude in micro mm, whereas a naught is the amplitude of standard earthquake, 3 micro mm. Now coming to seismograph. So what is a seismograph? It is an instrument used to measure the magnitude and intensity of an earthquake. So now we have studied about intensity and magnitude of earthquake. Now we will study about seismograph. So what exactly is a seismograph? Seismograph is nothing but an instrument used to measure the magnitude and intensity of earthquake. So how you will measure the intensity and magnitude of earthquake? Using a seismograph. So now let us see the studies of seismograph in detail. So earthquake hazards in India. The Indian subcontinent has a history of devastating earthquakes. The major reason for the high frequency and intensity of earthquake is that Indian plate is driving into Asia at a rate of approximately 47 mm per year. Geographical status of India show that almost 50% of the land is vulnerable to earthquake. Normally, if you see, we assume that we think that in India, earthquakes will not occur only in few parts like Gujarat, Kutch, it will occur. But if you study the geological features of India or geological statistics of India, 50%, that is more than 50% of the land is most likely to have earthquake. What is the reason behind is the major reason for high frequency and intensity of earthquake is that Indian plate is driving into Asia at the rate of approximately 47 mm per year. So it is a very high rate due to which more than 50% of the land is vulnerable to earthquake. A World Bank and United States report estimate that around 200 million city dwellers in India will be exposed to storms and earthquakes by 2050. So, a study shows that of the World Bank and United States that estimate that 200 million cities in India will be exposed to storms and earthquakes by 2050. Now we are in 2025. After 25 years, more than 200 cities in India are likely to be affected by earthquakes, as per the survey conducted by World Bank and United States. The latest version of seismic zoning map of India given under the earthquake resistant design of Code of India, that is IS 1893 Part 1 2002, assigns four levels of seismicity for India in terms of zone factor. So now what we are studying is how the zoning of seismic zoning of India is done. We said that the earthquake occurs in Gujarat, Kutch, but how to make zones for it, how the zone is being made. In other words, the earthquake zoning map of India divides into four seismic zones: zone 2, 3, 4, and 5. Unlike its previous version, which consisted of 5 or 6 zones. For initially, there were 5 to 6 zones, but what was done is zone 1 was discarded and zone 2, 3, 4, and 5 was kept. According to the present zoning map, Zone 5 expects the highest level of seismicity, where Zone 2 is actually with the lowest level of seismicity. This is what is understood. Normally, we are going from smaller to higher, that is 1 to 5. Zone 1, we are not considering. So, Zone 2, 3, 4, and 5. Four zone The entire India is divided into four zones: Zone 2, 3, 4, and 5. So, Zone 2 is the least affected zone, whereas in the Zone 5 is the most vulnerable zone. Now, which region comes in Zone 2? This region is liable to MMS 6 or less and is classified as low damage risk zone. So, Zone 2 is most unlikely to undergo an earthquake. The regions which are included in Zone 2 are most unlikely to have an earthquake. So, they are termed as low damage risk zone. The IS code assigns zone factor of 0.1. Maximum horizontal acceleration that can be experienced by structure in this zone is 10% of gravitational acceleration for zone 2. So what the IS code says, the IS code assigns zone factor of 0.10 for zone 2. So what are the regions that comes under zone 2? Bangalore, our capital city of Karnataka, Ajmer, Allahabad, Hyderabad, Pondicherry are the few notable cities under zone 2. So we are living in a safe area where the chances of earthquakes are very rare. Now comes zone 3. This zone is classified as moderate damage risk zone and is liable to MMS7 and also 7.8. The highest code assigns zone factor of 0.4, zone 3. So what are these? This zone 3 is known as moderate damage risk zone. So what are the regions that comes under zone 3? Kerala, Goa, Lakshadweep, Islands, remaining parts of Uttar Pradesh, Gujarat and West Bengal, parts of Punjab, Rajasthan, Madhya Pradesh, Bihar, Jharkhand, Chhattisgarh, Maharashtra, Odisha, Andhra Pradesh, Tamil Nadu, and Karnataka. Zone 4. So the zone is called high damage risk zone and covers areas liable to MMS 8. The highest code assigns zone factor of 0.2 for zone 4. So what are the areas that comes under zone 4? Jammu and Kashmir, Himachal Pradesh, Uttar Pradesh, Sikkim, and parts of Indo-Gangetic Plains, northern Punjab, Chandigarh, western Uttar Pradesh, North Bengal, Sundarbans, and the capital of country that is Delhi fall in zone 4. In Maharashtra, the Patan area is also in zone 4. In Bihar, another part of the state, like that's near the border of India and Nepal, is also in zone 4. Latur, Maharashtra is also in zone 4. So zone 4 is characterized as high damage risk zone. So finally, zone 5, the zone which is most likely to undergo earthquake. Zone 5 occurs, the zone 5 covers the areas with the highest risk. Zone 5, that's for the earthquake zone intensity MMS 9 or greater. The highest code assigns zone factor of 0.36 for zone 5. Structural designers use this factor for earthquake risk measure of structural zone 5. The zone factor of 0.3 is indicator effective 0 in is referred to as very high damage zone. So what are the regions that comes into zone 5? The region of Kashmir, the western central Himalaya, northern middle Bihar, the northern northeast India, the run of Kutch and Andaman and Nicobar group of islands. Generally, the areas having trap road basalt are prone to earthquake. So this is about the different types of zone. Zone 2, 3, 4, and 5. We are living in a safe place, that is zone 2, whereas which is a low risk zone, which low comes into zone 2 only, whereas zone 5 is the most vulnerable zone where the chances of what you can say earthquake is more, and the region that comes under zone 5 are the Kashmir, Western Central Himalayas, etc. So in the next class we will see what are the what you can say different uh, major earthquakes that occurs in India, that we will see in the next class. Thank you for watching. Have a nice day.